Chapter 3.7, Absolute Value Inequalities. We've already done equations. Your objective for this video is to solve inequalities involving absolute value. Before we can start solving, we need to talk about what you really need to know in order to solve these. So if I have an equation that is something is less than a number, A being the equation part and B being the number, then you are going to solve the compound inequality, negative B is less than A, and A is less than B. If you have a greater than inequality, you're going to solve the compound inequality, A is less than negative B, or A is greater than B. For example, if you have the inequality absolute value of x is less than 3, you are going to set up the inequality negative 3 less than x less than positive 3. And that's actually all you have to do for that one. If you had the inequality absolute value of x is greater than 3, that would be x is less than negative 3 or x is greater than 3. Okay, because we're doing the second part of 3.7 this time, we're actually starting with example 4. That's in your textbook under the section 3.7. But they give you the inequality, absolute value of 8n is greater than 24. While the key concept I think is great, I think we're also going to have to remember, I'm going to give you a little shortcut to remember this stuff. It's less than or equal to, that's going to be an and compound inequality. If it's greater than or equal to, that's going to be an or compound inequality. Maybe that'll help you to remember. So when I graph these, I'm going to take what's inside the when I solve them, I'm going to take what's inside the absolute value and set it greater than or equal to 24, or I'm going to take it and I'm going to set it less than or equal to 24, negative 24. Just like when you divide or multiply by a negative, you have to turn your inequality around. When you set it equal to the negative, you have to turn your inequality around. Then you're going to solve, so we're going to divide both sides by 8. You get n is greater than or equal to 3. And then over here, you're going to do the same thing, divide both sides by 8. And you get n is less than negative 3. Then they want, or equal to. Then they want you to graph it. So we're going to do negative 3, positive 3, and you're going to put a closed circle on negative 3 and a closed circle on positive 3. And this is an or, so we're going to shade outside. We're going to shade what's less than negative 3 and what is greater than positive 3. Okay, got it, number 4? Feel free to pause the video here and do this one on your own. I'm going to do the whole solution in just a second. Okay, take what's inside the absolute value. Since it's greater than, that's an or, so we're going to do 2x plus 4 greater than or equal to 5, just like it says, or 2x plus 4 less than or equal to negative 5. So subtract 4 from both sides, and you get 2x greater than or equal to 1. Divide both sides by 2, so you get x is greater than or equal to 1/2. Subtract 4 from both sides on the other one, you get 2x is less than or equal to negative 9. Divide both sides by 2, so you get x is less than or equal to negative 9/2. So your answer is going to be x is less than or equal to negative 9/2, or x is greater than or equal to 1/2. Then we want to put it on a number line. So negative 9/2 is like negative 4.5. So that's 0. We're going to go negative 1, negative 2, negative 3, negative 4, negative 5. And then obviously 1/2 is going to be between 0 and 1. So negative 9/2 is going to be halfway between negative 4 and negative 5, and it gets a closed circle. 1/2 is going to be halfway between 0 and 1, and it also gets a closed circle. And because this is an OR, we're going to shade outside of our point, so that's going to go this way and this way. Okay, example 5, solving an absolute value inequality again. This time we're going to use a word problem, but it says a company makes boxes of crackers that should weigh 213 grams. A quality control inspector randomly selects boxes to weigh. Any box that varies from the weight by more than 5 grams is sent back. What is the range of allowable weights for a box of crackers? So my weight cannot vary by more than 5 grams, which means that the difference between the actual weight of the box minus 213, how much it's supposed to weigh. So I'm going to put weight minus 213. The absolute value of that, because it could go in either direction, cannot be more than 5 grams. So it has to be less than or equal to 5 grams. So there's my inequality. It's a less than, so that's going to be an and. You have to remember that. So you're going to take W minus 213, and you're going to put it between -5 and +5. So you're going to solve the two inequalities, -5 less than or equal to W minus 213, and W minus 213 less than or equal to 5. And solve it, so we're going to add 213 to both sides. And we get 208, and we get 218. So the box has to weigh between 208 grams and 218 grams. Got it number 5. You can try this one on your own. I'm going to go over it though. So a food manufacturer makes 32 boxes of pasta. Not every box weighs exactly 32 ounces. The allowable difference is ½ an ounce. Write an absolute value inequality to find the range of allowable weights. So absolute value of the weight that I actually weigh minus 32 has to be less than or equal to 0.05. So that means that W minus 32 is going to be between 0.05 negative or 0.05 positive. So then we solve it. Negative 0.05 less than or equal to W minus 32, and W minus 32 less than or equal to 0.05. Add 32 to both sides, and you get 31.95, and you get 32.05. That means that your box has to weigh between 31.95 and 32.05. So if you write it like that, 31.95 less than or equal to W less than or equal to 32.05. Got it? Questions? Show all of your work, do all 3 questions on a separate sheet of paper, and then bring me your homework tomorrow for proof that you watched the video.